All right, here we go. Lesson 12, practice problems. Can't believe we're already in lesson 12. Anyways, who am I going to talk about today? Let's talk about Victor Wembanyama. I got lucky. I ordered a NBA Hoops set of packs for the new year, and one of the packs had 4 Wembanyama rookie cards. So he is off to a crazy good start. Won Rookie of the Year last year. He's 7'4", and he's got handles. He's got a shot. He's gonna probably be a threat to have the most blocks of all time. We'll see. But anyway, Victor Wembanyama. So look out for him. All right, here we go. Question 1. Match the directed line segment with the image of polygon P being transformed to polygon Q by translation by that directed line segment. Now, those directions are pretty wordy, but basically what you do on that is you figure out which arrow matches the move, essentially. Now, P is the same, so I'm just going to trace P to show you what they mean by that. Now, patty paper is your best friend on translations and rigid transformations. So here we go. You're going to want to borrow some of this from class in order to get your homework done. So here we go. Let's get P traced, and I'll show you what they mean by this question. This is a fairly interesting or easy problem. Whoops, did something wrong there. Probably getting fed up with me wasting your time, but anyways, I want to explain it fully. Okay. So we start with P, and if you look at this point to this point, those are corresponding points. If you look at the move, you can see that the directed line segment is right here. So which of these 4, A, B, C, or D, matches this directed line segment? Because in a translation, you need to describe the directed line segment. And as you can see, there it is. So this one's going to be A, right? So you got to match all 4. Okay, let's go to number 2. Number 2. Draw the image of quadrilateral ABCD when translated by the directed line segment V. So the image of this one, quadrilateral ABCD, when translated by the directed line segment V. Label the image of A as A prime, the image of B as B prime, the image of C as C prime, and the image of D as D prime. Now, a couple ways you could go about this one. Couple ways. Here's the easiest way. It goes over to the right 1, 2, 3, and goes up by a half. So A, B, C, D, the whole shape is going to move over 3 and up by like a half of a triangle side length. 1, 2, 3, and then half, right? 3 units over to the right, and then half of a triangle side length. So what you're going to do is just go point by point. Start with A. 1, 2, 3. A prime is going to go up by a half. So we'll call that A prime. And you have to do that for each one of these. 1, 2, 3, and then a half. 1, 2, 3, and then a half. 1, 2, 3, and then a half. And then make sure you get these prime labels. You're going to have 4 points with prime labels. And you'll see this is the same as line segment, directed line segment V. It's going to be parallel to V, same distance and direction. All right, number 3. Which statement is true about a translation? Well, I'm going to use this example to explain number 3. 1, 2, 3 and a half. 1, 2, 3 and a half. 1, 2, 3 and a half. D prime. This should help you see it. Realize I'm giving you the answer for 2 by using this to explain 3. That's okay. All right, so we got this shape right here. This is the image of ABCD, and it's known as A prime, B prime, C prime, D prime. Now let's talk about this. A translation. This is an example of a translation. So a translation takes a line to a parallel line or itself. Now look at AB. That's a line segment, right? When we translated it, it went to A prime, B prime. Are these two lines parallel? Let's look at BC. Here's BC. When we translated it, line segment BC, it went to B prime, C prime. Is this line parallel to this line? Let's look at DC. Here's DC. Here's D prime, C prime. Yeah, are these two lines parallel? What about this entire line compared to this entire line? Do those two lines ever intersect? So what do you think for A? A translation takes a line to a perpendicular line. Let's look at line DC. When we translate it, it went to line D prime, C prime. When we translated it. So is this line perpendicular to this line or parallel? A translation requires a center of translation? No. It requires a directed line segment. A translation requires a line of translation? No. A reflection requires a line of reflection. They're trying to confuse you there. So what's your answer on that? A, B, C, or D? Okay, number 4. Select all the points that stay in the same location after being reflected across line L. Now, This is from a lesson that we skipped, which means I'm going to give you the answer. If this is our line of reflection, the mirror, B prime is going to be like right here, right? B prime. D prime is going to be like right. These are not perfect, but D prime is going to be like right here. A prime is going to be like over here somewhere. Right? So, which points are going to stay in the same location after being reflected? C and E, because any points along this line will stay in the same point after being reflected. After being reflected. So your correct answer, C, E. That's a lesson we didn't cover, so I'm just going to give you the answer. Okay. We're almost done. Number 5. Only 11 minutes in. Okay. Lines L. Here's line L. And M are perpendicular. That means 90 degrees right here. A point Q. Oh, this is lesson 11 too. I get to give you this one. A point Q has this property. Rotating Q 180 degrees using center P, here's P, has the same effect as reflecting Q over line M. Give 2 possible locations of Q. All right. That could be one. And this could be one. And I'll show you why. I'll show you the patty paper move. We'll just call this Q1 and Q2. So here's P. Here's Q, our first one. If we do a 180 degree rotation, Q1 at 90 degrees will be here, 90 degrees counterclockwise. There's about 135, and 180 is going to be right there. It'll land over here. So let me show you that one more time. 180 degree rotation. Let's just go the other way just for fun. My first Q will land right there. Here's a little trick you can do. So you can see through it. This will be like Q prime. See how reflecting over line M, if we reflected over line M, it would also have the same effect. So basically you're looking for points that are on the line. Now let me show you the second point that we tried out. Let me try this one. And why don't I do a little bit different color so as to not confuse you. Okay, here was the second one. Wow, that's terrible. Pencil. Okay. So watch 180 degree rotation. Doesn't matter which way, it's going to end the same spot. Here's 90. 90 degree clockwise would end on line M. 180 would end up right there. The center P. So just for kicks, I'm just going to make a mark so I can see through it. This would be the point of it. This would be the 180 rotation. So a 180 rotation would end up right there. So these are 2 points that would work. This would be Q prime for the second. This would be Q prime for the first. So in both instances, a 180 rotation center P is the same as reflecting over M. See how these are reflected over M? This one's reflected over M. So as long as you chose 2 points that were on line L, that would have worked. B, do all points in the plane have this property? Nah, I'll show you why. Let's just say this is J, right? If I was to reflect over M, J prime would be like right here. But a 180 rotation center P would take us over here. This would be J prime right here. So reflection over M would be here. 180 center P would be here. So no. To make sure both points are on L. Do all points in the plane have this property? No. Any point off L will not satisfy both a 180 degree rotation center P and a reflection over M. Okay, cool. Number 6, there is a sequence of rigid transformations that takes A to A prime, B to B prime, C to C prime. The same sequence takes D to D prime. Draw and label D prime. Okay, so what you want to do on this is trace A, B, C, and D. Label them A, B, C, and D. Take A to A. Rotate till B lines up with B prime. And right there is going to be D prime. There. D prime. Okay. Two distinct lines, L and M, are perpendicular to the same line N. Okay. I'm going to use this patty paper, or this pack of yellow paper to show you what they mean. So two distinct lines, L and M. Why don't we call this top line L? And this line right here, M. They're each perpendicular to N, which we'll call this line. So in case you're wondering what, Fisher, what? Let me show you. Let me just draw the lines to make it a little clearer. This will help us explain what they are talking about. So there's L. Here's M. And they're both perpendicular to the same line, N. Okay, so we got two lines, L and M, perpendicular to the same line, N. That's the scenario that they're asking you to imagine. What is the measure of the angle where line L meets N? Well, that's easy. What is the measure of the angle where line M meets N? So there's the two meeting points. What's the measure of the angle? There's only one correct answer for both of those. All right, that was lesson 12, and it was only 20 minutes. All right, put in 20 minutes for the concept statistic.